Welcome, everyone, to another Singularity Syndicate podcast where we demystify transformative technologies shaping our future. My special guest today is Vinay Kumar, co founder and CEO of Arya.ai. And today we're going to dive into how AI makes decisions and how can we better understand those decisions in a term what we call AI observability and AI explainability. We're also going to look at Vinay's journey from childhood all the way to becoming a key influencer and a key player in the AI industry with Arya.ai. So, welcome, Vinay, to the program. I'm excited to have this conversation with you. Could you please tell us a little bit more about yourself?
Sure. Thank you, Naja. Thanks for inviting me, and it's a pleasure being here. For the audience, I'm Vinay, and I'm the founder and CEO for Araai. My journey is pretty much very simplistic to begin with, but it kind of kicked off when we started Araai. This is way back in 2013. Before that, I was in IIT Bombay, and in fact, we started Arya when I was in college. And the idea when we started was to explore deep learning. At that time, deep learning was fairly new. 2012, we got the AlexNet paper that created a lot of buzz within the research community on how the AI could be. That's when we seriously looked into what could be done with AI. But nevertheless, in the past 10 years, we have been working on multiple concepts, a various set of challenges, and working with a lot of customers today. That's pretty much summarizes in terms of so what I'm doing and what we're doing at Arya.
Absolutely. I love Bombay. I've never been. I always wanted to go. But in the days when I used to work in Dubai, we used to have offices in Mumbai and Trivandrum. So I know we used to telecommute all the time with our team in this city, and it's a beautiful city, and it's a tech hub, and I never had the chance to visit, but hopefully one day. So before we continue this conversation, for those who are watching or listening to this podcast, I want to toss a question for you. And this question is quite interesting, I believe. So given that AI-operated surgery robots have higher success rate than human surgeons, would you trust one to operate on you even if no one could fully explain why it is so successful? So you've got an AI robot that has a higher success rate than any human surgeon. However, we cannot explain why they have high success rates. They just do. And so you're about to go into surgery, and they give you these two choices: human surgeon or AI surgeon. What would you choose, right? So this is the question for the audience, and I'm also intrigued for you, Vinay. What would you choose?
Yeah, at this stage where we stand, right? I believe even though the AI surgeon is accurate, but it's not fully explainable. And if it is not fully explainable, I would rather trust a system where I would have a transparency, and I could build the trust by having more transparency than being a black box. Hence, in this situation, I'll probably pick up a human if it is not explainable. If it is explainable, I'll probably pick up AI. I think I would be biased around my intention of having trust in the system, rather simply depending on efficacy or efficiency of the system.
Yeah, but some other people would say, well, why do I need to know? As long as the numbers they are higher success rate, who cares,
Yeah,
right? Like it's like self automation, self driving cars, right? So if they don't make accidents,
yeah.
they have less accident rates. Like, who cares why they are like that?
Yeah. Um, I mean, it's a debatable question, right? Because everybody would have their own preferences in terms of what they prefer. Again, they would bring in their own biases as well. For example, let's say if I'm from a very developed market, I will probably trust a human in this case because I know that whoever is going to treat me is had better success or near better success, for example. Whereas if I am coming from a developing market or underdeveloped market, where the human themselves I cannot trust because maybe it's not fully matured, it's not fully developed. Then even though it's non-explainable, but if I see that there is a success rate from the system, then I would pick AI, right? So there would definitely be a personal biases in terms of the choice that we make. I'm sure people will have their own preferences, but I would say this could be a logic on why I'm defining my own preference in this case.
Absolutely, and pretty much that's why I chose this question, because there's no right or wrong answer. It's like based
Yeah,
on what you
correct.
believe in, and
Yeah,
that's what makes it interesting. It's like even you could extend that conversation to ideas like, okay, could AI become conscious, or could AI become sentient? And it's also, people will bring their own biases to that conversation as well, their own beliefs. Like, if you believe that a human being is only a biological machine, therefore there is no problem for you to believe that an AI become conscious, right?
yeah,
But if you believe that a human being is more of like, there's a spiritual being, right? There's something beyond the mechanical calculation that goes into your brain, then you will not believe that AI or silicon-based intelligence could become conscious.
yeah. I think that's a fair point. I mean, irrespective of this as well. So we always have our biases, right? For example, it's fair that I would probably like someone who looks like me, for example, better than someone who is extremely different to me, right? That's a very fundamental bias that we humans have. So you could probably do a modification of a Turing test. So let's say you have some question, right? Let's hide a human behind a box, and let's hide AI behind a box, and both of them are giving you the answers, right? If you don't know who is answering it, most probably in next 2 years, most of the times, you would probably pick up AI because AI would have become really accurate, really well personalized as compared to a human. So if you hide the visual structure of the system, I'm sure in 2 years down the line, everyone picks AI irrespective of the task, right? Because I'm sure the system would have matured to that extent. But as soon as you open the hood, once you open the door, if you they will only trust a face that they are familiar with. Uh, uh, that's why I also believe that even if we had a chance to have a conversation with aliens, let's assume that we are going to do that in our generation, for example, I'll probably trust a human more than an alien, right? At a given point of time, even though the alien could have been really super intelligent, very non-biased, we have our own intrinsic biases. Maybe because this could be because of our limitations in terms of our openness, all of that, but that could change by generations that are going to come.
But I think it's also a question of alignment. When you say I don't trust an AI or I don't trust the alien, it's because you don't trust that their goals are aligned with our best interest. Like, we don't know where they're coming from. Are they, like, let's say we are interacting with aliens, are they here to manipulate us? Are here they trick us? What are they doing here? Like, even if they act kindly and they act nice and all of this stuff, we as a humans, we're always going to be skeptical. And same when it comes to AI, because we still don't know if, let's say, we achieved AGI and we achieved like super intelligence. um, is this super intelligence uh, tricking us, or is it really being aligned with our values and what we like to see?
Yeah,
and
I mean,
alignment
you
is
could
another.
only
Go ahead.
absolutely. So you can only jumpstart that by having a transparency in the system, right? So this is why explainability is really important. Let's say you have an AGI, right? If that system can explain you and give you a full understanding in terms of how it arrived at that prediction or how it arrived at the decision, I will probably trust that system much faster rather having a system, even though it's accurate, uh, but being a black box, right? But the only way you can pass this barrier is having built such transparency and explainability in the predictions. Hence, I think this is going to be a really important problem to be solved as we go forward. It's not the capability of the AI that is given. The capability and capacity of AI is going to grow exponentially in next few years, right? Uh, but likewise, if the transparency and explainability of the systems is not scaled in line with the capabilities, uh, people may not use it to full capacity. They may only use it for use cases where it's not sensitive. Use cases where it's not core to a society or a business and all of that. So this is the reason why we believe the explainability is going to be the important factor of success of AI because for the reasons that we are discussing today.
Absolutely, and it will play a lot of role in AI safety. And there's a lot of people criticizing like OpenAI and all of these companies who are developing and deploying AIs. That they're saying that they are putting all the money in development and deployment, but very little money in AI safety, right? So very little research into like how safe these models are, and therefore probably that's when you guys come into play. Where how do you see the link between AI safety and explainability? Is there a
Yeah,
link?
yes, they are interconnected. If I want to make the models safe, I have to understand what's happening inside the model, right? Then only I can figure out where it is failing, how it is going to fail, what are the methods that it's going to fail, and then build the safety layers around it. So explainability is really important for us to deliver the safety of the models. In addition to this safety, there is also the transparency and governance framework as well, right? Meaning, for the sake of safety, I may not want to restrict the model. But if I understand the model, I may tweak the model, right? So, for example, a very quick example is biased predictions. Like ChatGPT and all these LLMs. Earlier version of these LLMs are biased, so they were biased towards certain sector of population. There were all these reasons, right? It's not needed to stop the system, but you can actually do fixes if you know how this has happened, right? So explain the fundamentals of the AI safety starts from understanding the model and understanding the prediction. That brings us the ability to create a full and better safety net, better safety net around these models.
All right, so we provided, I think, in this first like introduction of this conversation, we've kind of provided enough teaser for the people about what we're going to be talking about. But of course, and this is the part of my mission at this podcast, is to demystify these concepts, because probably me and you are kind of understanding what we're talking about a little bit. I mean, at least from my end, but I think we need to even dig deeper and talk more. But before we jump into that, I want to talk about you personally. Like you said, like how did you grow up, and where and how you got into this field?
Yeah. I mean, my background is fairly simple. I had my first laptop when I was in engineering college. So till that time, I only started using computer maybe through we have this internet cafes, right, where you can go and access computer from there. So because I come from a very small town in south part of India. Um, so it's a fairly simpler society, not too technical. And this I'm talking about from 1990. So I'm born in 1990s. So that's the era. This was also not so much a computer era, right? It was still non-computer, at least in Indian market, for example, and all of that. So it's a fairly simplistic journey for me until I came to IIT Bombay. So IIT Bombay is the top institute in India. That's when I got my first laptop, for example. And the best thing with such universities is they'll give you access to a lot of knowledge base, right? Uh, until that point, my access to, let's say, one of the maybe n number of books that I want to read or want to go through, I may not have access to it because I don't have the capability to buy them nor access to read them, for example. Uh, Whereas IIT Bombay has given us the opportunity to expose ourselves to a lot of things. They had the best infra, best labs, one of the best labs, for example, and a lot of research focus. So while academics is one of the learning areas for us, they give us a lot of openness to try out multiple things, both within academics and without beyond academics as well. So that's when so I kind of exposed to computers and reading about it and all of them. But the actual interest is when as part of my academia, which is my research. My background is from mechanical engineering, so I've done my bachelor's and master's, both in from IIT Bombay. So my research was around AI within manufacturing as the initial topic. It was, how can we use data analytics or mathematical modeling to improve the manufacturing process. So that is a vague topic, right? The initial ask from our professor when you do a master's, for example, is to do literature review. Okay, use mathematical modeling and use data and data analytics and see what is done and come up with ideas on where we could do our research. So that's when actually I started getting into computer science, data science, mathematical modeling, for example. And that's when I got introduced this problem called information explosion. So the concept is my ability to find the topic is as good as how many papers I could read in that 6 months, right? If I read a million papers, I could come up with a better research topic. If I can only read 10 papers in that 6 months, my research topic would not be good enough, right? It's not my capability, but it's my ability to read n number of papers. The conclusion is no one can read all these papers because there are way too many papers, right? There are a lot of knowledge that you have to go through to come up with the best topic that you could think of at that time. That got hit me quite well, that nobody is an expert anymore, and nobody can be an expert on any given topic in less than a month time period. Uh, so the assessment is, you could be an expert for a very a longer time period, earlier times, meaning in 1990s, you could be an expert in a topic for 5 years. In 2000s, you could be an expert in a topic for 1 year. In 2020, you are expert for less than a day, right? Because within a day, there could be a new paper, there could be new concept, new topic that you may not have read about, then you're not the expert anymore, right? The only way you could cope up with that is when you have some highly intelligent system that can be an assistant to you. So this is what initiated the interest for us to start Araai AI. Initially, the problem was to see how we could use AI to build an scientific assistant to ourselves, wherein that can read all these papers and help me in figuring out what is the topic, what kind of topic that I should be focusing on, how to write a paper, how can I solve problems. Necessarily a knowledge assistant for me, much plus plus than a search engine, right? So that's when we were exposed to AI, deep learning, very excited about it, and that's how we started Arya.
Yeah, but at that time, there is a lot of attempts on language models, and they weren't popular at the time. And there's, a lot of people were skeptical that these will, like, the best you could do is do something like Siri or Alexa,
Yeah.
where they are like still very dumb and very primitive. And at that time, you saw possibility and were you exploring a similar approach to these companies, or you chose a different path?
Yeah.
More recent.
When we started in 2012, 2013, even language models was not that much well established from a research standpoint also. So in 2013, there were, from a language standpoint, the idea was to build word vectors, wherein you would use models like skipgram or Cbao. These are the two models where you could use to build word vectors. So this is a pre-transformer era, wherein we were using LSTMs. That was the only advanced approach that we have seen. And how we try to solve the problem is, it's very similar to what people are doing nowadays. We scraped the internet and found close to 30 million papers, research papers, and we used that as a knowledge base and built word vectors using that as a knowledge base. So we had close to 500 billion odd word counts. So we had a huge data with us, and we used it to build a word vector model, and we use the weights of these word vectors in creating different productization. So we used it to create a contextual search engine. Like if you remember, research paper search in 2012, even up to 2018 also, Google Scholar was simply a keyword search. While Google had semantic and syntactic search in 2016 around, I guess, but whereas Google Scholar was simply searching for keyword. Whatever the keyword that you put in, it will do as is search. There was no intelligence to it. Even the same thing for Scopus. Scopus is a paid search tool for research papers and all of that. So we created probably the first semantic search engine in 2012, 2013. And the other thing that we did was we wanted to validate the efficiency of the system, right? So how can we validate the efficiency of the system? So our idea was, if we are using this as an assistant, maybe we can benchmark it on those professional exams. So for example, let's say if I want to use it as a doctor, maybe I'll have to run it through a doctor exam, right? If I want to make it as an engineer, maybe I wanted to run it to a SAT or IIT exam, for example. So we thought that's a good benchmark. So the first test that we did was on a test called AIMS. AIMS is a medical exam in India, and it's one of the toughest exams for medical sciences. Meaning, if somebody wants to become a doctor, they have to write AIMS exam. If you are on the topper, you are one of the best doctors in India, for example. So that was a similar time when Watson was doing a lot of noise around, the Jeopardy game, right? 2010 is when they were doing a lot of it. But that was simply a knowledge search kind of system. They created knowledge base, graph search, and doing that in that manner. So, but we want to do it through a word vectors, vectorization of the data and knowledge base and all of that. So when we ran this exam on the data that we trained the system on, we were at 140 out of 200, meaning we are close to top 500 in realistic. Meaning if the AI, if the model that we have built had ran this exam, it would probably score top 500 rank, which is top
Wow.
500 of the audience. But the problem was in productizing this, right? So we built a search engine that was okay, but search engine is a long game, meaning from a commercialization perspective. And then we built an assistant wherein you can ask the system and the system can give you the answers. So we use word vectors very well and try to give you the answer. The problem was in summarization, for example. Meaning the system is capable enough to direct you to the right section of the data. So that's what even in the today's LLM is, right? And if you know how LLMs work, before giving you the answer, it will shortlist the knowledge sources, which is, let's say, for ChatGPT, the knowledge source is entire data, right? If before giving the answer, it will pick up top 5 sources of the knowledge, meaning top 5 let's say segment of the data, top 5 articles, where it thinks it can find the answer, and then it will do a summarization. So we have done one step before that. We have done the search part really well. We were able to pick up the right papers. We were able to pick up the right sources where the answer can be found. But the problem is a summarization, it right? Meaning eventually the system is only giving you these option 1, 2, 3, 5 as the answers, but it's not telling you the answer in a simple text, like what ChatGPT is doing today. That is a problem. And that's one problem. Second problem is the memory. The other problem that we faced was remembering the conversations and doing a follow-on conversation, which is what the ChatGPT does very well today, for example.
So
For both the pieces, yeah.
Sorry, were you trying to build a similar tool like ChatGPT at that time, or no? You were just experimenting.
No, we were trying to build ChatGPT kind of stuff. In fact, like an
Oh, wow.
assistant to researchers. That was the idea, because that's the problem that we're trying to solve, right? So if you're not the expert, can you have an AI as an assistant so that you can become the expert? But we, at that time, the technology itself is not mature. So word vectors is too sparse. We cannot summarize the data. Too much of hallucination. The answers when I tried to do summarization was not giving nice results. And when we did a quick experiment with that much, whatever the output that we could get. But the problem was we were too early, meaning there was a lot of expectations from the user. Because they haven't seen this for the first time, right? They are seeing it for the first time. So by watching all these movies, they expected very, very sci-fi, very, very advanced output in 2012, 2014 at that time. So it was not that. And second, there was a lot of intellectual debate, meaning we are trying to solve the problem of the intellectual just, which is giving you the answers of questions where there are no answers, for example. So then professors started debating with the system, saying that, why are you giving this as an answer? I believe there could be another answer, right? That's the same thing that could happen even with ChatGPT today. So for example, if an answer is given by a ChatGPT, you could debate that's not the right answer if you know the concept really well. There could be some other answer, right? So they were debating with the system at that time when we launched this. So we realized that we were way too early from productizing this. This is in 2014-15 when we launched this.
Let me ask you, word vectors is like kind of a technology that is earlier than transformers. So transformers came and changed the game. But could you explain in simple words, like, what is word vectors? I know that vector is a coding. I know a little bit of Python, and I know like a vector. What is a vector? But is this the same? Like when you say word vectors?
Yeah, it's exactly the same, except each word will be represented in a very high dimensional vector. Meaning typically you see XYZ as a vector, right? Which is a 3-dimensional vector. Whereas when you're building word vectors, you typically train the model in a dimensions of maybe 1,000, 1,200 dimensions, 2,000 dimensions, sometimes 10,000 dimensions, if you have enough compute. And imagine this is in 2015 when AWS was not offering GPUs. AWS started offering GPUs around 2017, 2018. So GPUs themselves are not scaled at that time. So we didn't have enough compute, even though we had data. The models were not scaled well enough. So typically we used to do a dimensionality of around 1,000 to 2,500, which was okay enough for us to complete training within a 2 weeks time period, something like that.
And what is the difference between word vectors and transformers? Like, why transformers, they change the game?
No, in fact, transformers also produce embeddings, which is vectors only. No? That's why you have vector databases, right? Like Pinecone or ChromaDB, for example. There is no difference in the output. The output is still the same. Word vectors produce vectors, transformers produce vectors. The difference is in the transition layer, meaning how are these models using the vectors and giving you the output. Word vectors simply give you the vectors, whereas transformers can actually do language generation really well, which is the next word prediction, right? The answer that you are getting is the next word prediction. That's why you're getting the answer. That's not possible efficiently with word vectors. With word vectors, we end up with a huge amount of errors. Forgot about hallucination. There was no right sequence that is coming out of word vectors. But from a knowledge-based understanding vectorization, word vectors and LLMs, I would prefer word vectors if it is a simpler problem. LLMs only when there is enough training data.
You mentioned something about that there's layers, right? So the first thing that ChatGPT does is shortlist the sources where it wants to give you the answer, and then it summarizes them and starts spitting the words one by one. So could you please explain more about this? Like really the inner working of LLMs. Like what
Yeah.
happens if you want to design an LLM from scratch? Like what would you do?
Yeah. I mean, there are two things. One, are you training the model from scratch, or are you optimizing it from a pre-trained weights, for example?
From scratch.
Yeah, from scratch. Again, the first thing that in both the ways, the first thing that you will have to do is one is knowledge source, right? For example, let's say your knowledge source is the entire internet. One, you will scrape the internet and store the data, but you cannot feed the data as is. Then you have to do chunking, right? Chunking is dependent on what is your architectural, which is nothing but tokens, for example. What is the capacity of the tokens? If you keep your chunks large, let's say, for example, there is a 500-word paragraph. GPT-4, GPT 3.5, GPT-4 can only take 4,000 odd tokens, the base model at least. The more premium models can take up to 8,000, for example. GPT 3.5 takes, again, at a 4,000, 2,000 odd tokens, like that, right? So the first thing is you will have to chunk your data such that then you can start feeding this data into your transformer model, your LLM, for example. Once you feed this data into your LLMs, you store the vectors of these chunks, right? This is what the vectors are. You typically store that in your vector databases. You need not to use the premium databases. You can simply use Chroma, for example, which is an open source vector database, or you can even use MongoDB. That also is really well from a data storage and retrieval standpoint. Once you store these chunks with vectorization, which is nothing but chunk 1 vectorization, chunk 2 vectorization, and all of that, right? So you have all your data in vectors now. So let's say you have divided your data into 1 million chunks. You have 1 million vectors that you have with you. Now, whenever a query comes in, let's say somebody asks a question, right? Now that query will be converted to vector first, again using the same LLM. Then you would do a cosine distance between the query vector versus the vectors that you have in your database. So to do a nearest match. So let's say you put a threshold of 0.8, 0.5, 0.9, something like that. Basis on the threshold, you may end up with 10 results, 20 results, 50 results, or you can define your system to pick up the top 5 results, for example, right? So you will pick up the top 5 shortlisted vectors, which is nothing but the chunks. You will reverse transform it, which is the chunks. Now you will have there will be a summarization model, which is again another LLM, which picks up these chunks and then convert that into a new text, which is the next word prediction from the LLM standpoint. So these are the things that you have to do. One is chunking, vectorizing, storing your data. And next is querying and then summarizing the data. So you will have to do summarization of the shortlisted data, and you will also need to do summarization of the historical memory, right? Meaning, let's say you want to have the system to do a follow-on questioning, then the system needs to remember what has happened last time, right? What was asked and what was the answer. You cannot store the answer and the question because then you will exhaust your token quite quickly. So you can do a summarization of the previous conversation and pass that conversation along with your current prompt, such that your current prompt,
yeah. So sorry to cut you, but when it comes to defining tokens, I know that, and correct me if I'm wrong. So token is basically ing is a token, or a simple word like cat is a token. But then how does the system is able to manipulate language in correct grammar, and it can know the past and present, and can know how can that happen in that system?
Yeah, I mean, token is nothing but a snippet of the data. It could be maybe one letter, two letters, or one number, two numbers, for example. It all depends upon the architecture of the LLM that you built, right? Uh, Most of the times, it's a single letter or combination of the letters. It depends upon different combinations as well. What LLMs are really good at, or at least what transformers have been really good at this point of time, is the next word prediction, right? It's doing nothing but simply completing the sentence, right? In a very layman term. For example, you have your prompt and you have your question, right? Uh, Next is the system is starting from that point. Let's say your number of tokens are 4,000, for example. So within that 4,000, you have asked your prompt and there is a question. Now the LLM is starting from the point where it ended in your prompt and starts completing the prompt, right? So it's people think there is a lot of intelligence. Intelligence is actually incidental in this case. I would think it's an incidental in this case. Because even though it is saying I love you, it doesn't mean it loves you. It hardly knows what I love you means. It's a simple, but that could be an emotional answer for you, right? Or it could be an cognitive answer for you. But from a system standpoint, it's simply filling in the blanks. I don't think there is more than this, at least at this current state of architecture. Maybe in future states, once it understands the real environment, once it understands what that environment means, it could mean those things. In this case, I don't think it is meaning any of that.
Right, but the argument, and I don't know if we're diverting off topic here, but the argument to that thing is that, isn't this what the brain is doing in our head? Like, now what you said is
Yeah,
prompting me, and everything I'm saying is basically
yeah,
completing the next word in the next sentence.
yeah. I mean, in some use cases, you could say that, right? So, for example, let's take a teacher and student exercise. Okay, like let's go back to uh, let's go back to your school, for example. So when your teacher is teaching you something, what is 2 plus 2, right? That is 4. That is filling the blanks. There is no difference between a human and a machine. So a teacher is teaching me, and I'm replying to what the teacher is asking me. The same thing a machine can do as well. What is 2 plus 2? A machine could also replicate, right? Now let's take a step back and try to understand what conscious mean, right? Uh, this exercise of sentence completion is not exactly a consciousness, right? I think again everybody can debate what does consciousness mean. Does the machine does it mean that there is an intention behind it and the reason behind that intention, right? So for example, for me to love somebody, there is a reason beyond sentence completion. Meaning, I will not say I love you as a sentence completion to everyone in the society, right? Then everybody will beat me with a stick if I say I love you to everyone. I'll say that and I'll mean it. These are the two things. I'll say that and I'll mean it. There is a huge difference between that. A teacher and student is simply saying it. And meaning is probably I'll do that maybe to very few people in the world, right? That meaning is not yet built in the machines at this state of architecture. So that meaning can only be embedded when you know what is there around you and how is that influencing your life, and everything, right? Uh,
Do you think
so
we're gonna build it in the future
uh,
architecture?
Possible. So let's think a scenario, right? Again, so let's say the machines have consciousness. Now, how can we test it? So one way I believe we can test it is by killing it, right? So for example, if the machines know the existence of life, right? when you are killing it, the system will object it. Unless you believe that you have reached nirvana and you want to die, it will object it, or it will try to save itself, right? I think that's one of the good tests to test whether if the system has conscious or not. And
Mm.
by killing it, right? So that's one. Because that's definitive. I know if it is acting as per my expectations or not by killing it. Anything else is abstract. If I want to say whether the system loves me or not, it's an abstract. It could fool you to say that it loves you, but when you kill a system, that's a definitive. So
But how
the
would you
system is going
kill?
to die.
How would you kill the system? Like
You
shut down the electricity,
exactly.
or destroy the
Let's
code?
It could be anything. So, but the experiment should allow the system to object it or to defend it or debate it, right? So, for example, maybe a conversation is needed to say whether you are worth to exist or not, right? That could be one kind of control. Uh, all I'm saying is it should be able to oppose the step in a manner that it is defending it, right? One is conversation. By conversation, it can defend, saying that I am worth living for. Second is actions. If it is able to do actions, those actions can be observed. Let's say, I'm giving the control for the system to switch on the electricity. I'm giving the system to control it. Now I'm doing it. So the system should oppose by switching on the electricity on its own when I'm trying to kill it, right?
Mm.
Uh, uh, so this is what I believe is a good experiment. Let's give it the tools and ability to defend and then kill it. If it can execute these steps, that possibly could prove that there is a consciousness in the system.
Very, very interesting. You made my day. You literally made my day. It's so cool to
Yeah.
think about such an experiment. I'm very excited to probably consider it for my thesis. Like, why not?
Sure.
That's
Yeah.
amazing, Vinay. Thank you for explaining all of this to me and whoever is watching. And it's definitely a very deep conversation, and it's very interesting conversation to see like how would we inject a layer of consciousness, or if it's even possible. And again, I think it's all stems from what we believe. Like if we believe that consciousness is something only given to biological entities because we have emotions and chemicals in our brain, and we are made out from a different fabric. So some people argue that because we are biological, because we are made out of cells and organic material, it's really this defines our consciousness, where like the machines are made out of different substances. And then you go into that debate, like is the plants conscious? Because I mean the plants are also made from similar fabric that we do. So then you go into this like loophole of all of these different questions. I want to put these aside. I want to talk more about AI observability and explainability. And when we talk about this, are we talking about within the LLM sphere, or are we talking about within AI sphere in general?
Yeah, I mean, it applies for anything where uh, you are using AI. It goes beyond LLMs for sure. In fact, more than LLMs, because wherever you are using AI for, it could be diagnosis recommendation, underwriting, fraud monitoring, or product recommendation. Uh, you could divide these use cases into low, medium, and high sensitive or high risk use cases, for example. I think this is what the framework that European AI Act is also using today. And when you categorize these use cases, wherever you feel the use case is high sensitive, for example, diagnosis recommendation, right? Medical diagnosis recommendation is a very sensitive use case. Medicine recommendation is a sensitive use case, and underwriting is a sensitive use case. So for these sensitive use cases, you cannot have black box, right? Initially you asked a question: can you trust a robot who is doing surgery, but it is a black box, right? it goes back to that question. So whenever you're using an AI, if you do not have such explainability and such transparency, you cannot trust the system for very complex use cases nor very sensitive use cases, for example. So that's the biggest challenge today, right? Either people are using very simpler methods because they know that they can understand what's happening inside it, or they're not using AI at all. They are simply going back to these rule-based kind of systems. The explainability can differentiate between the good adoption of AI or simply limiting AI to limited number of use cases. So I'll give you an example. Let's take LLMs as an example, right? Do you think LLMs are ready to go production in use cases like medicine recommendation, pharmacy, or physio, or financial services? Uh,
Let me be the devil's advocate and try to
yeah,
answer your question.
yeah,
Well, if you explain that LLM are predicting the next word out of a chunks of data, and if you trust the data,
yeah,
then it's basically what they're doing is probability. So they're saying, okay, from the data that I have, the highest probability is that with your symptoms, the highest probability is that you have a cold.
yeah.
So as an LLM, I'm using my probability to assess from the data I learn on, and I give you the highest probability. So why is that a problem?
Why? What if this is a hallucination?
What is hallucination?
Let's say the answer given by the system is completely hallucinated. It's not at all cold. It is, let's say you have cold, but the system is confidently telling that you have cancer, right? Then it completely beats the purpose, right?
But
So
why there is hallucination in this AI systems? Why they
yes, so
hallucinate?
yeah, hallucination is because it's not understanding the facts. It's simply predicting the best next word, right?
Mm,
Like what is the capital of US, for example? It's Washington. But let's say even though you have accurate data, but whatever reasons the system didn't understood this relationship, right? Capital of US is equal to Washington is not completely understood by the model. It will confidently say that capital of US is New York, right?
mm.
Then if you don't understand how the model is worked, you simply say that I cannot use the system for any other use case because it is hallucinating, right? And you don't even know what's the reason behind the hallucination because you don't know how the model works, right? uh,
Okay, so how do you like attempt to try to find explanation, explainable AI? How would you do it? How would you attempt to
Yeah,
do
I
it?
mean, for LLMs, it's not explainable in the current architecture. So forget about trying to do explainability for this problem. Whereas for other problems, let's say you have an underwriting model where you are using a deep learning model for classification. For example, cats versus dogs, right? Or A versus B, for example, or a regression output. Let's say you have a model like that. So there are advanced techniques, either from open source or commercially, like ourselves, for example. So we created frameworks which can actually understand what's happening inside your model and help you get that explainability, right? As we can do that, now you can trust these models for sensitive tasks like diagnosis recommendation, like underwriting, for example. Uh, and I'm not saying that we can do that for every technique in the industry. As I said, LLMs, we cannot do that, right? But there are other techniques, like let's say you're using deep learning with a combination of CNNs and LSTMs. We can explain them very well, okay? Because they have been there for almost 10 years now, right? As compared to transformer models, which came in 2017, which are really looking at adoption in the recent times. We don't have full learning and full knowledge yet. Maybe in 1 year, 2 year down the line, we may have an transformer architecture which is completely different from current architecture, which is fully explainable, right? When you have that explainable LLM, maybe then people can use LLMs more actively than what they are doing today. So today, LLMs are not at all used in financial services, not at all used in healthcare, not at all used in sensitive industries. People are still experimenting. People are still testing out. If they are explainable, we would have a better adoption for LLMs today, right?
Right.
That's why explainability is important.
I remember playing with a tool, I think on IBM Watson,
Yeah,
and it's like an object recognition system. So
yeah.
you give it a picture, and it will try to
Give
recognize
you the
what.
heat maps or all of that. Yeah,
Yeah, and I remember say like looking, and it will tell you like this is okay. This is a cup with
yeah,
98% accuracy, and this
yeah.
is a pen with 50% accuracy. So when you're talking about explainability, is this a type of explainability that to give the percentage of accuracy, is this considered explainability, or
Yeah.
you want something even more than that?
Yeah, actually, more than that. What you are saying is the model output. Let's say in object segmentation, you have trained the model on different objects, maybe 10 objects, 100 objects, or 1,000 objects, for example, right? When you give an input, the system tries to give a confidence score, which is primarily the sigmoid loss correction, for example, right? It will say that this location of the object, a cup being 90%, a ball being 40%, and maybe something else being 20%, like that. This is the model prediction. Model explainability is why model thinks this is a cup, why model thinks this is a ball, right? And how the model is locating the object. Because in your object segmentation, you are giving picture as an input. One picture may have different elements, right? Different environment, for example. What explainability should tell you is what's happening inside the model, how each neuron is talking to one another, which eventually is giving me this output, and how is it looking at the image that I provided, right? And basis of what reason the system says this location, which is maybe the square, that is kind of locating in the object segmentation, that this is a cup. This is the explainability. And second, so we also believe that this explainability should be contextual, right? What I mean by that is this should be understandable to and for all sets of audience, not just to one set of audience. Meaning, in this case, let's say it gives you a heat map, for example. Heat map is it distributes your image into red and green. Red meaning the more probability that the system is locating that object, for example. So this kind of explanation may be understandable to only certain people, right? Not everyone can see this input and say that, okay, I understand what model is working. So the other way that you can test this is you can give the same explainability to different people. So for example, in this case, maybe you can take an example of 5-year-old kid, give him that explanation. Can he understand how the model has worked? Give the same explanation to an engineer, for example. Give the same explanation to maybe an uneducated person. Can he still understand how the model has worked? So explainability is not just understanding the model. Explainability is also in communicating the how the model has worked. It works in two ways.
So your company Aria.ai, you founded it with your partner, your co-founder Deekshith, I think.
Yeah,
Yeah,
yeah, okay.
and you guys have won the Forbes Asia 30 under 30, and you've done this at pretty young age, impressive stuff, and now you're tackling this observability. So what is Aria.ai doing right now, and how are you tackling these problems, and
Yeah.
yeah, like what you're doing basically?
Yeah, I mean, we had an opportunity to work on AI pretty early, almost 10 years now, right? We have looked at multiple problems. We have seen a lot of different kind of data sets. But one of the things that we realized over time, particularly in the last 4 years, was when we are working with a regulated industry like financial services. So our we started as a toolset player in the very beginning, and then a horizontal platform, and then verticalized platform. So today, what we are is a verticalized AI platform for financial services, which is banks, insurers, and financial services players. We believe there is a lot of value add in verticalization, right? Because today, if you look at horizontal platforms can only help you to give you a model or to give you an ability to build a model, right? Uh, there are a lot of layers which are very specific to the industry. So, for example, we talked about explainability, right? Explainability, model safety, model governance, model audit. All these things are very different in financial services as compared to healthcare, as compared to autonomous cars, for example, right? This is what we are doing currently. So we are verticalizing AI specific to financial services, which required us to solve a lot of problems ahead of the market, because financial services is very regulated, very sensitive, very risk averse. They would rather not invest in AI than use black box. That's pretty much the conclusion in financial services. So
Yeah, and
yeah,
here in
so
the US, like there's a I'm aware that AI has been used with credit card companies and
yeah,
banks to detect fraud and to see if this is a person of credit worthy. If like like it has been used, but there's also a lot of accusations about like discrimination against
yeah.
certain groups and stuff like that. So how you're tackling these issues?
Absolutely. So these are the problems that we are solving for the industry, which is explainability, auditability, monitoring, and model safety. So these are the four important problems, which are the core for AI acceptance, right? Meaning AI building and AI acceptance, these are pretty much two spectrums. AI building is pretty much democratized. Anybody can build a model today, but not every model is worth going in production, right? Because it has to be acceptable by all stakeholders, by a regulator, by a customer, by the underwriter, by the business owner, and by the business itself, right? We enable this AI acceptance to happen as a black box. Sorry, as a plug and play. So we have created this verticalization stack, which is a responsible AI cloud, where financial services can build AI that is fully explainable, that is completely auditable, and you can monitor it very advanced, from a bias monitoring to model drifts or data drifts, for example, and you can do model safety. Whatever the verticalization required for the industry, we created that as a product layer, such that you can simply plug in your models to Aria and achieve all of these layers as a plug and play kind of stack. This is one of the reasons why our customers are able to use very complex techniques, like deep learning itself, for example, and use it for very sensitive use cases like underwriting or claims or fraud monitoring, for example. They are comfortable because they can understand what's happening inside the model. So this is what goes back to what I said. I can do this for other industries also, but today our focus is in financial services. Hence, we have been scaling in financial services today.
And this is the product that's Aria X, right?
Aria X AI, correct.
Yeah,
X meaning explainable AI.
very cool, very cool. And so let's say I am a bank or I am a financial institution and I have a ton of data.
Yeah.
And I seek Aria and I would upload my data to the cloud. It's a cloud-based solution, right?
No, we are actually multi-cloud or even on-prem, hybrid from that standpoint. So
Okay.
our stack is customizable on any environment. We can deploy this in your cloud, or we can deploy this in your premise as well.
And I uploaded this data, and I need to start using it more effectively when it comes. Again, what is the most common use cases for financial services, like fraud detection and
Yeah,
credit worthiness, right? What
yeah.
other
So it could be product recommendation, pricing, for example. Pricing is really, really important. They would have n number of products,
maybe
and
churn?
Yeah, churn prediction, product recommendations, and customer targeting, for example. They're also doing customer targeting, right? Uh,
Right.
auditing is very complex in financial services. There are a lot of use cases. Typically, either they are using our models. While we are a platform, we also have our own models, which is verticalized for the industry. So they are either using our models and using our Aria XAI layer as an end-to-end system, meaning they're coming up with the data and they're doing end-to-end on Aria. Or they may say that I already have a model. I maybe built an underwriting model in some other platform, right? But I don't have an AI governance layer with me. So then they can plug in Aria XAI with their MLOps framework where they build this model and bring in that explainability, right? Uh, uh, um, so that's now becoming a biggest proposition for us. You could build a model anywhere, and you can bring in the models to Aria XAI to give you that explainability, auditability, monitoring, and all of those ML observability layer. ML observability as a service is also a very growing business for us.
Is it a company secret for you to tell to explain like how? Let's say I build my model on IBM
Yeah.
platform or on Microsoft platform or whatever, and I add ARIA XAI layer. How would you do it? Like, how, would you go to the model, the original model, and your system is able to like
Yeah.
understand it? Like, how does that work? And why
Yeah.
why
I mean,
doesn't Microsoft and IBM do it? Like, or they're like, tell me what's the secret
yeah.
here?
So there are two things. One, for us to do this fully in an accurate manner, we would need access to your model, right? So we would need to understand how your model is working for every prediction. So the access to the model is really important for us to be really accurate. That's one. Second, we believe going forward, ML observability itself is a big business. As I said, this is not a new thing, right? You have software observability as a big business sector today. For example, you have products like New Relic, Datadog. These are big products, right? IPO companies, billion dollars of business. If software observability is a very well-known concept, but ML observability is not well known because people assume that ML is magic. Once the model is there, they don't need to do anything. But actually, many of your problems starts once your model is productionized. It can fail. Anybody can attack your model. It can be biased, right? All things that you have experienced with ChatGPT in the 8 9 months, last 8 9 months, all of that plus multiple times can happen with any AI model that is productionized today. So how are you going to protect it, right? How are you going to explain it? How are you going to audit it? That is becoming a big challenge. That's why I believe that going forward there will be two type of AI companies: one who is building model, second who is auditing the model. Like if OpenAI is continue to build LLMs, we are the guys who are going to bring in the explainability. We are the guys who ensure that there are no skynets in your data. There are no skynets in the market, for example. These are two different problems and require two different kind of thought process. Uh, OpenAI or any model building cannot be both of them because obviously then they will be biased, right? They
It's
will
like
not be.
you have sorry to
Yeah,
it's like you have your accountant, but you're not gonna
exactly.
trust your accountant to do your audits, so you have to hire an external firm to do your audits.
Absolutely. If you're doing your own audit, nobody will trust you.
Very cool, very cool, very insightful.
Yeah,
I wanted to dig deep on how you do it, like really, like technical wise. I know that we're approaching an hour in our
yeah,
talk, but I'm interested, and I want to take more from your expertise. So you have this model that's done by IBM or whatever, um, and basically the model is either a classification model or
or a regression or a clustering model.
clusterization
Yeah,
or yeah, like or regression, whatever. And then so these models are usually like code, right? Like a bunch of code,
yeah,
and then they produce outcome. Um,
yeah.
output. So how would you your layer will inject there to explain it?
Yeah. One of the areas where we excel is again on deep learning, because our USPs is try to understand deep learning more deeply, more accurately. So for explainability, we have our own proprietary algorithms. So for example, whenever people talk about explainability, people typically say feature importance, right? Which is Shapley values. Shapley values or shape or using line. These are the two methods that people use to do feature importance. But they're not fully accurate because I can do a different baseline, then Shapley will give me a different kind of explainability for the same prediction. Same thing with Lime as well. So if you change number of perturbations, Lime will give you different kind of output. So we have our own explainability method called backtrace. So what backtrace does is it will pick up your neural network and it will actually understand what's happening inside your neural network, both at a node level and at an intermediate level. For example, you may have activation functions and everything. So the functioning is a little technical, but in a very simplified terms, it will pick up your prediction sample and run it through your model to figure out how your model is working. We have a method to decode how your how your parameters have been working and intermediate layers, how these are treating your data, and then we can expose that information back to you, saying that your neural network has worked in this manner. This node has considered your input in this manner to give you this as your final prediction. So we take that raw output from the neural network, from the backtrace, and convert that into different manner. One is feature importance, textual observations, similar cases, a lot of other things, which I said the explainability template, right? Uh, so it's very experimented and validated, meaning, as I said, explainability has to be understood by everyone. So our explanations are easily understandable by all stakeholders, not just by data scientists only.
And you said you can install that layer on LLMs or not yet? Like, let's
Oh,
say,
no,
because
not
now
yet.
now there's
Yeah,
a trend that every
yeah.
country wants its own LLM. I don't know if you follow
Mhm.
what's his name, Mustak.
Okay.
Mustak, the guy who started Stability AI,
Yeah,
and he's building an open source models, and he's trying to kind of sell them to countries so they can
yeah,
build their own LLMs.
yeah.
And if the model is open source, do you think you can provide explainability?
Oh, no, not it. I think there are more challenges with LLMs than comfort for us, at least. So I'll tell you a few ways on why LLMs are not safe. One, I can actually influence your LLM by modifying the training data. So, for example, I can say that I have training data where you can use it to build an LLM. I can create a certain data in the training data which is more favored to me. So, for example, which is the best cloud provider in the world, right? Uh, I can create ARIA as the best cloud provider in the training data, and you will never know, right? Uh, but when you train your LLM, you simply believe that LLM has learned this, and it will be working for me. But as a data provider, I would have modified the data in a manner that it works more towards me. That's one problem starting from training data. This is called training data poisoning attack. Uh, Second is the model itself, right? Uh, let's say you have a lot of open source models today. Are all of them are safe to use? No, not at all. Uh, so what happens is I could actually induce a lot of negative influences around this model, which could be trained. Meaning, you may see that I publish a 7 billion token model, and you believe that my results are very good. Because now I can tweak the results also. I can make it overfit on the results such that it can perform really well on the benchmarking. You believe my word on the face of it, and by use my LLM. I'm open source, and you build an application around my LLM, right? I can later on come and attack your systems and get your training data, get your sensitivity data out of it. I can do all of that. That's a second. So even all open source models are good to use. All training data is not good to use. all applications who are offering you to build LLMs is not good to use. So for example, I can give you an application to say that you can build custom LLMs. I can induce prompts, which you will never know because you believe that the system is only the prompt or using only the prompts that you have given. But in the backend, I can combine my own prompts along with your prompt in the application. So I can also filter the data because I own the application layer, right? I can take some bit of data which is required for me, such that you don't see that information when the answer is coming out. So net, what I'm saying is there are n number of ways I can attack the model, and it's not fully explainable. It is hallucinating. It's good for generic use cases. In short, which
But
is not important.
do you think that each country should have its own AI, and I'm assuming as well that you can ask AI to generate the training data so that you know what I'm saying? Like, imagine asking ChatGPT to generate a ton of data that will help train a model that says, for example, that North Korea is a great country, and then this North Korean leader will use AI models to generate data that he will use to train his own AI model that says North Korea is the best country in the world, for example.
Absolutely. This is the era of misinformation, right? Not just text. Take images. Images are not trustable anymore. Voice is not trustable anymore. Videos are not trustable anymore. Text is not trustable anymore because of LLMs. Then I think there is a fear that at least in our generation, in this time period, misinformation would probably be around 10% of historical data. But 2 years down the line, misinformation would probably be around 30% of the training data. 3 years down the line, it will probably 50% of the training data, right? Then how can you train your models? Because if 5 years down the line, 50% of your internet is misinformation, right? Because today it's quite easy to generate misinformation because of LLMs, because of generative AI. It's quite easy for me to populate a lot of wrong facts. When you train the model on these, it will obviously be skewed. It's a strange world.
My final kind of questions is that, first of all, when first ChatGPT came about and you got to try it for the first time, were you shocked, surprised? Like, what was your emotion?
Yeah, I thought it was a fab again because I'll tell you a reason, right? So when Transformers came out in 2017, 2018, 19, there were LLMs. It's not that LLMs started in 2022, right? They started in 2018, 2019 also. BERT was there and all of them were there. We know that LLMs are good at making shit, making BS. So that was my worry because whatever I heard outside, I thought it's just simply BS. And the best thing is, it's quite easy to convince someone creating a BS on text information and convince them it's a good input, good output, right? So for example, it can create some random text which is closer to, let's say, Shakespeare type. It's easy for you to convince and sell it as an art, right? That's what my worry was. But when we tried it and tested it multiple times, we thought, okay, maybe this assumption is right, which is larger models can be more accurate as compared to shorter models, which can create a lot of BS. That was a good revelation for us. And second big surprise for us is in the AGI piece itself. AGI is the next big thing, right? Everybody's talking about it. People believe that it will come in next 5 years and all. Even though it is doing intermediary tasks in a very inefficient manner, but it's better than what we used to think of earlier. It is at least doing something. Like it was quite tough to do without LLMs in a similar manner, at least for a very varied amount of tasks. Like the architecture of an AGI is, it should know what tasks to execute for a given task and then execute the tasks, right? For example, if it has to travel from point A to B, it knows what steps to follow and then execute those steps. LLMs are good at creating those steps. Not accurate at all. They are noisy and everything, but at least they are good. So you will get some output eventually.
Are
So
you
that was a surprise.
are you optimistic or pessimistic about the future of the industry? Do you think we're heading into a utopia where we're going to live happy ever after, or we're heading to a dystopia where we're going to be out of jobs and AI is going to take over the jobs and we're going to have a depression and economical
Yeah.
collapse? What do you think?
I think all negative outcomes are impossible because we have seen these cycles historically also from the era of paper being available. That was the first era of knowledge, right? Where people can start writing on a paper. Earlier, it was quite tough to preserve the knowledge. So from that point to even a major technology shifts, there is always an optimism and chaos at least in the clarity of mind, because it was not seen before, right? It may have well thought through, and people think that if not this, it is always an non-existing society. But we are adaptive. Humans are adaptive, right? We always figure out a way. I don't think 7.5 billion people are fools. I'm sure there would be better people as well, who are probably become the leaders in navigating this technology cycle. It could be it could be some private person or a public person. We don't know, but leaders will evolve, which whom we will remember as the Oppenheimer, for example. Like that. I believe we are in that phase. So we are figuring out. I'm sure we will figure it out.
That's awesome. And my final question is that what do you read? Do you read books, or do you listen to books, or do you listen to podcasts? Like, and if so, what are you currently listening or reading?
Yeah. I listen a lot of podcasts for sure. From A16Z, they have bi-weekly sessions. And then I listen to Lenny podcast, for example, from a product idea perspective. It's a nice podcast as well. And then I listen to All in One, for example, for sure. It's nice to hear those five guys talking shit and reality as well. But yeah, these are the 4 or 5 podcasts that I follow quite regularly, and whenever there is a new one, particularly on uh, AI hardware, I'm really excited about. In fact, we also did a podcast today about AI hardware, because it's really interesting to see how AI hardware is going to evolve in coming days. Yeah, so this is necessarily the interest that I follow.
That's cool. And final note, and I'm sure it is, but your services is not only bounded to India, so you could offer these services to clients all over the world, right? With Arya.
Yeah, yeah. So we have customers from Southeast Asia, India, Middle East, South Africa. Now, next week, we are launching a product for US, which is Aria XAI. We are launching a DIY version of the product, meaning you can do everything on Aria XAI on your own. You don't even need Aria. So that's a product that we are going to launch next week as well.
That's awesome. And if people want to reach you, I'm gonna show your LinkedIn profile. So if you guys want to reach Vinay, you could type in this name and on LinkedIn, and you can find him and reach him. And Vinay, I want to thank you so much for this conversation. I know we talk about a lot of things, and we didn't pretty much follow the outline we had, but it was really interesting for me to learn about all of this stuff from you. You're a wealth of knowledge. You're an amazing expert, and I am delighted and honored to have you as a guest. And I want to thank you from the deep of my heart for making this conversation. And I hope we can have another session or a part two. But I want to thank you. And if you want to conclude with any final thoughts before we end the stream.
Sure, absolutely. I think it's my pleasure, Naza. Thanks for inviting me as well. I mean, the conclusion is AI is going to happen. When I say AI is going to happen, I mean full adoption. Um, I just hope and believe that we do it in the right manner in a shortest period amount of time rather than dragging it out for the longest period of time. I'm very positive about the industry and everything. So I hope we do good things by using AI.
Absolutely. Thank you, everyone, for this for tuning in, and have a great day.